Hi everyone, so welcome to day 2 of graphing quadratics. So pause and do this practice SAT problem. So notice it's equivalent, right? So all we're going to do is multiply out. That's our double distributing. So we have, I'm going to ignore the 3 at first. So I have 2x times 4x plus 1, and then 1 times 4x plus 1. 8x squared plus 2x plus 4x plus 1. Combine the middle two. 8x squared plus 6x plus 1. And now I'm going to put that 3 back in. So distribute the 3. 24x squared plus 18x plus 3. So it's C. Okay, what was that formula that we use to find the vertex of a parabola? That is negative b over 2a, right? So remember, the vertex of the parabola is this bottom point right here. It's the point that's probably the most important point of a parabola. It could also be upside down, and it would be this point right here. So this is the x value, right? That's the x value. How do we find the y value then? Well, we take our answer, and we're just going to plug it into the equation. Right? So plug in your answer to negative b over 2a into the equation to solve for the y value. So our vertex is always a point, right? It's that negative b over 2a, whatever we get there, and then our y when we plug in. And then when you plug in. All right, so I want you to pause and try this problem on your own. So we're going to start with our negative b over 2a. So that's negative 10 over 2 times 1. Remember, it's ax squared plus bx plus c. Our b is the number in front of the x, so negative 10. So we get 10 over 2, which is 5. So remember, we're graphing a parabola. So this is 5. So we need a few numbers on either side. So we're not going to put the 5 at the top. We're going to put it in the middle of our table. And then we're going to pick numbers on either side. So counting backwards, 5, 4, 3, and then 5, 6, 7. So those are all the numbers we're going to plug into our equation, x squared minus 10x plus 21. So we're just plugging in and seeing what we get. Four squared minus 10 times 4. 5 squared, 10 times 5. And 7 squared. All right, so I plugged into my calculator and I got 0, negative 3, negative 4, negative 3, and 0. And remember, we want to look at our y values. The vertex is the one in the middle. And then on either side, it should repeat. That's how we know we did this right. So plotting 3 is 0, 4, negative 3, 5, negative 4, back to negative 3, back to 0. And then we can plot more. If you wanted to, say, plug in 8, what's that, 5? So we can go 8, 5 if you want. And then there'll be a 5 over here. And that's our parabola. Okay, now try this one. Same idea. Be careful with your negative b over 2a for this one. So negative 14 over 2 times negative 1. Make sure you pause and try this on your own. You get negative 7. So then negative 8, negative 9, negative 6, negative 5. Just think about it as a number line. So now we're plugging in. Now be careful with this one. Make sure when you plug it in, it's negative x squared minus 14 times x minus 40. And then the negative 9 goes inside. Make sure you put it in your calculator like that. If you don't put the negative in front of the parentheses, it will mess up your answer. If you get, basically, if you're plugging in and you get crazy numbers, you probably typed something wrong into your calculator, because I usually check these problems so that it works out. Or I won't give you a normal grid. Sometimes I'll give you something else. If I give you just like something that looks like that, like just lines, that's when you know that, oh, okay, the numbers are going to be a little wonky. And we're going to do that on the next lesson. Okay, so now I'm going to plug all those in my calculator and see what I get. All right, I got 5, 8, 9, 8, 5. Let's see, negative 9, 5, negative 8, 8, 9. All right, so those are our points. There's my parabola. Now, here's the question. What are the x-intercepts? So the x-intercepts are where the graph crosses the x-axis. So the question is, on the other video we did, I kind of let you estimate, how could I find these exact points? So you have a choice. You could try and hope for the best and plug in negative 4 and negative 10 and see what happens. In that case, it works because negative 4 is 0 and negative 10 0. So the x-intercepts are x equals negative 4, x equals negative 10. But then what if it's a really weird number? We have to have a way to do this. So on the x-intercepts, what is the y value? These points are negative 4, 0 and negative 10, 0. So the y value is 0 on the x-axis. So 0 equals negative x squared minus 14x minus 40. Do we know how to solve that? We do. That's what we spent the last few weeks working on, right? We're solving a quadratic. So I can divide everything by negative 1. 0 equals x squared plus 14x plus 40. That we can just factor it. What multiplies to 40 combines to 14. 4 and 10. Set each of those equal to 0. And subtract. So what we were finding, all those problems that we've been doing the last month, when we were solving quadratics, we were actually finding the x-intercepts. We were finding where the parabola crosses the x-axis. All right, so how do you find the y-intercept? So the y-intercept is when you plug in 0 into the equation. And it's always the c value. Right? So remember, we have ax squared plus bx plus c. If we let x equal 0, we get y equals a times 0 squared plus b times 0 plus c. So the a and the b end up going away, and we just get c. So your y-intercept is the c value. To find the x-intercept, that's what we just talked about, that's where we're setting the y equal to 0. My eraser's not working. We plug y equals 0. The x-intercepts are what you get when you solve a quadratic using factoring, square roots, or the quadratic formula. So those methods that we were practicing so that we could find the zeros where this thing crosses the x-axis, right? Because y equals, so 0 equals ax squared plus bx plus c. We now know how to solve that. Okay, so pause, I want you to graph it like normal, and then I want you to write down what is the y-intercept and what are the x-intercepts. So let's see if this turns out nice. So we got our negative b over 2a. So negative 12 over 2 times 3. That's negative 12 over 6, which is negative 2. Negative 2 goes in the middle. Negative 3, negative 4, negative 1, 0. So now we're plugging in to 3x squared plus 12x plus 3. 3 times negative 4 squared, 12 times negative 4 plus 3. All right, so I paused it to not waste time writing. So then I plugged in everywhere, and then I plugged these in my calculator. I got 3, negative 6, negative 9, negative 6, and 3. So this one is going to be one where it doesn't really work out nicely. So negative 4, positive 3, negative 3, negative 6. Are you warmer? Sorry, I got interrupted, and I always get confused when I get interrupted. What am I doing? I'm plotting. All right, negative 2, negative 9, negative 1, negative 6, and 0, 3. All right, so this is a skinny one. Here's my skinny graph. Okay, so this one we don't know. Like, it's not going to be a nice number. So because these are not going to be nice numbers, we need to solve the quadratic to find the x-intercepts. So 0 equals 3x squared plus 12x plus 3. So we could try to factor it, but I'm pretty sure this is not going to be factorable because it's going to have a weird answer. So let's use the quadratic formula. So x equals negative b plus or minus the square root b squared minus 4ac all over 2a. Negative 12 plus or minus all over 6. Let's see what we get under the square root. 12 squared minus 4 times 3 times 3. I get the square root of 108. Now, with these, if you want to get the decimal, I'm good with that, because it's kind of weird to leave these as a radical, because I want to know where does this cross the x-axis. If you want to leave it, you can. It's really up to you. So this would be 108 simplifies to 36 times 3. So we would get negative 12 plus or minus 6 root 3 over 6. So our x-intercepts are negative 2 plus or minus root 3. Or if you want to plug it in and get the decimal, you get, sorry, I'm running out of space. I'll change my color. X equals negative 0.268 and negative 2 minus root 3. Negative 3.732. Okay, if you give me the decimal, give me 3 decimal points. So you have a choice. Either give me the decimal, 3 decimal points, rounded correctly, or you can give me the simplified square root. All right, here, the last one is the easy one. What's the y-intercept? That's just our c value, 0, 3. Right? That's it. All right, pause and try it on your own. All right, so I got my negative b over 2a, negative 3 over 2 times 2. Ooh, 3 over 4. This is not going to be fun. All right, 3 over 4 goes in the middle. All right. Now, here's what we're going to do here. What integer comes before 3 over 4? 0, negative 1, 1, and 2. So this one's going to be more challenging. Don't put lots of decimals. Just think about the number line, right? 0, 1, 3 over 4. So pick the integers on either side. The only problem is when we do that, We're not going to have that repetition we had before. It's going to be, the numbers are going to be a little weird. All right, so now let's plug in. All right, so I got 0, -5, -6.125, -6, and -3. All right. So -1, 0, 0, -5, 3/4. So that's a little bit, it's just to the left of 1, and then -6. So it's something like that. It's okay. We're going to have, that happens with these. 2, -3. All right. So it looks super awkward, right? That's okay. Just, we can do it. We can do it. There's my parabola. So whenever you have a vertex that's a fraction, it's going to be weird like this. It still is a parabola, but the numbers are not going to be necessarily repeating because the distance between the vertex is different. Okay. Y-intercept. What's the y-intercept? 0, -5. Axis of symmetry. What's the axis of symmetry? X equals 3/4. And now the x-intercepts. So we have to solve 0 equals 2x squared minus 3x minus 5. So this is actually factorable. So 2x, x. Oops, 2x, 2x. I forgot how I did it. If I did in my head, I'd do 2x and x. 2x, 2x. We are multiplying to -10, combining to -3. Right, remember we multiply those. So that's -5 times 2. Divide by 2. 2x minus 5 equals 0. X plus 1 equals 0. And we actually already had the -1, right? We had that point. So x equals -1. And then over here we add 5 and divide by 2. So x equals 5/2. All right, one more. Okay, this is the one that messes everyone up. Everyone always freaks out. So I want you to pause and see what you can do with it. So if I do my -b/2a, what is my b value? ax squared plus bx plus c. What number is in front of the x? Well, there is no x, so it's -0/2 times 4. What's 0 divided by 8? It's just 0. -1, -2, 1, 2. All right, plug in and see what we get. So I get 6, -6, -10, -6, 6. All right, so -2, -6, +6, -6, -10. So this is a super skinny parabola. The vertex is 0, -10. Right? What is the axis of symmetry? X equals the vertex at 0. The y-intercept is our c value, 0, -10. Now we have to solve. So how do you solve 4x squared minus 10 equals 0? Well, notice there's only an x squared in the problem. So I'm going to add 10 to both sides. 4x squared equals 10. Divide by 4. X squared equals 10/4. Take the square root of both sides. Plus or minus the square root of 10. The square root of 4 is 2. So that's my answer. Again, if you want to put it in the calculator, you can. All right, and that's it. Here's your homework worksheet. Shocking, I know.